say decide to use divide and multiply, and your random number came up as 0, you're going to crash the code. Same thing with log and exponential, if you're using those.
Actually, that's not always a bad thing. Well, it's not going to run for what you need. If you divide by 0, it might crash your code, but so does half the JavaScript on the net. You know, you've got a cursor with stars flying around it. If that's not working, you're probably okay with it, and it's not going to throw an error. So if your code doesn't always mutate properly, it's still going to run, or it's still just going to sit there, and they're not going to see it. Because the chance that like the one time it doesn't work falls in the lap of someone who's looking for it is pretty rare.
I mean, how many people have seen that little box that IE pops up, which is like, there was a script, would you like to debug? And then there is a debugger built into it. You have to have Visual Studio. I see that box all the time. It's very annoying because people don't know how to write very good JavaScript. So this would not be abnormal if you saw that. Boolean literals can be expanded too pretty easily. So instead of saying, like, if flag equals false, or, saying variable, is logged on flag equals true, you can say, just replace it with an actual inline conditional. Alive is equal to, 5 equal 5, or 7 not equal 3. So expand them that way. A lot of people talk about string literal expansion. We'll just break the string in half, escape sequences. One of the things you should notice here is that, like, when I do that decompose, I take SPI dynamics, I break it into 2 strings, I increase the length by 3 characters because I have 2 extra quotes and a plus. If you look at actually using like ASCII codes to actually represent your strings, I mean, you had 6 characters, right?
It's what, 300, 600%?
Yeah. Now you've got this string from char code. I mean, it's more than that. It's huge.
Which then you've got to bring it back too, and as it starts to grow, so that could blow up your code within 2 or 3 generations to just be enormous. So what started off as maybe a K could turn into like 2 or 3 megs.
You know what?
That's not going to look like normal web traffic, and that can get the worm caught.
We'll just jump to a demo because that's a lot more fun than us talking about it.
Yeah.
So this is just a really simple factorial example. So there won't be massive amounts, and I have to change that to be a minus. There won't be massive amounts of mutation that can occur here. But so I'm just going to run the code, and I'm taking the factorial of 5, 120. And so now I'm just going to start mutating it. And we see that it's changing. Not by a lot, it's still 120. So I'm taking things like, variable equals variable minus 1, and we can actually recognize that and mutate it. And here we see we're using the minus equals operator. I'm changing between while loops and for loops. I'm renaming. We don't do any function ordering. You would need some pretty complicated static analysis to figure out which statements depend on which other statements and where you're allowed to reorder. Which
is not that bad when you're talking about PHP or JavaScript. Perl, on the other hand, not that fun. Perl is not a lexical language, so the only thing that can really interpret Perl is Perl. So like you end up in this really, really nasty piece where you can't run through and tokenize Perl properly because $_ sucks a lot. So yeah, it's not that hard for JavaScript and PHP and things like that to build a tokenizer and to actually do it right. But Perl is kind of a lost cause.
So it helps us. We like it.
Yeah, like in more ways than one, it's a lost cause.
So intelligent variable renaming. One of the things we see when people talk about source code mutation is they say, oh, we'll just rename the variables. Well, there are 2 big problems with variable renaming. One, you have to know what you're allowed to touch and rename and what you're allowed to rename it to. For example, you can't rename keywords, right? You can't just use a regex to find alphanumeric, strings and then just mutate them. Also, you can't mutate things that might be environment-supplied objects, like in JavaScript, window, document. You don't want to try to mutate $_ because that's kind of meaningful in Perl. So there are certain global objects, supplied functions, things like that from the environment that you can't mess with.
But like you can set things like document and window to like A or B or some sort of variable, which at first glance is fine, but if you're doing some sort of static analysis on it, it's going to get caught.
Exactly, because they're going to have to. Basically, our point is that you're not going to be able to use signatures anymore, and WebSense and FinGen are already starting to do very primitive, it appears, static analysis. They don't really talk about what they're doing. And believe me, I tried to get them really drunk last night so they'd tell me, and it didn't work. Something about proprietary trade secrets, I don't know. I tuned them out.
Non-disclosure.
So what we're trying to say is that you're going to need to do detailed static analysis, and setting, the keyword window to a variable and then using that variable farther down the line. I'm going to be building standard usedef chains. I mean, all of these things are familiar to people who know about compilers. I'm going to be able to trace every use of that variable, and you're not going to be able to really hide that you're using window from me. So also, you have to know what to rename it to, right? Not do a random character sequence. We found that source code obviously is not English prose, right? I mean, you're not reading Emily Dickinson here. But it's similar in a lot of ways. In fact, JavaScript and Perl can be dark and depressing and foreboding just like Emily Dickinson, especially when you're trying to debug it. And why doesn't IE have a debugger? I'm looking at you, Microsoft people. So I know there's a free one now, but I mean, it's no Firebug. You guys got a long way to go. So no sane developer uses, I'm picking on y'all a little much, I'm sorry. So no sane developer uses that as variable name. I mean, camel case is pretty much the de facto thing that people use now. You want self-documenting code, this is what they're teaching in colleges. I mean, of course, back in the day, they thought Hungarian notation was all the rage, and now we kind of, shudder when we see it. So, this could be out of date in a couple of years, who knows. But what you need to do is we need to not randomly generate a variable name, we need to randomly generate a variable name that looks like a real variable name. So we do this by generating camel case. We say, let's generate 2 or 3 words or things that look like English words and then case them appropriately so we end up with something. And you can't just randomly pick number between 1 and 26 and use that as a letter, right? You have to use character frequencies. E is 12%. I mean, 12% of all letters are E. At least in the English language when, you're doing, by the way, we're pulling all this stuff. I mean, this is what they do in frequency analysis. And breaking very basic crypto algorithms. They use these types of things. Same things with digraphs, pairs of letters. So you have to build these in. We actually did not get to finish the variable renaming. As you saw, my variable names were pretty bad. But this just makes sense. It's some slight modifications. You apply weight to certain types of letters, apply weights to certain pairs of letters. Also, you need to generate reasonably length words, right? You only want things that are like 5 letters. You don't want to generate 28 word long thing. And also, the ratio of vowels to consonants in English it varies a little bit. The longer the word, the lower the ratio. But I mean, look at source.
Yeah, it sits
right?
around
source is 50% vowels.
40%, yeah.
Prose is what, 40% vowels. Yeah. So, these things are, you want to try to make it similar to what they have. One thing you can do instead of trying to generate words to go ahead and change variable names is use nearby words. So if I've got a command execution vuln on the server and I'm running code, I'm just going to grab the Unix dictionary and pull some words out and slap together platypus and peanut. I don't know. That would be really weird if you ended up with 2 P words.
Yeah.
You can also grab files of the web root, right? Just grab HTML files or text files and just pull out English words. You might end up with, like the license file, and that would be really boring generated word. Hereinto, relinquish, a lot of lawyer talk. Also, you have to be very careful, though. On the client, for example, you could go ahead and just use JavaScript to say, let me look at the entire page, let me walk the DOM and all the text nodes, pull the text out of them, and use those. But in this case, you're actually dealing with English words. So the probability that you're going to get something that's a keyword or a global word, something that's reserved, is higher. The chance I'm randomly going to generate the word with or for or this or null are pretty small. But if I'm grabbing them from a page, it gets a lot more likely.
Which is why you've got to check back to make sure that it's not a safe word.
Exactly. And we'll tell you how we actually implemented this stuff towards the end. So this is just a function to extract words from the document. Code block creation. This is something we did not do. It was suggested in a couple of the little pieces of literature we read. Basically, on the left you've got 3 statements, and so instead what you do is you just break those statements out into functions and call the functions. The reason we didn't do this is that multiple generations down the line, you're going to end up with nothing but lots of little one-line functions that are getting called. And one-line functions that call one-line functions that call one-line functions that finally actually do something. This is really dangerous. You can have a lot of unchecked growth if you're trying to do code block creation. And also trying to collapse these things back down is really hard. It's easy for me to take 3 statements and wrap them in dummy functions and then call them. It's very hard from an analysis point of view, an automated point of view, to say, yeah, these 3 functions, can I actually break those back out into just their statements and inline them back in? So,
which we didn't do it more because we're really lazy on this one, because it's the whole tokenizer thing where you've got to do it properly and then it's grammar guided.
So we actually didn't implement, the way our mutation engine works, we did not actually implement a full-blown language tokenizer and parser. What we do is we run through the source code we want to mutate, and we build a table of where all the strings are. From this index to index this is a string. We then use regexes. You can show them the code a little bit, parts of the code.
Sure.
We then use regexes to try to find the beginning of where, or while clauses, the beginning of if then else trees, things like that. Do a little bit of a state machine to get the whole block, and that's what we do. So we're not doing full-blown static analysis.
Yeah, so there's
because that would be a lot of code.
Yeah, like there's stuff where you've got like 47 nested ifs. It might not catch it properly.
Correct. And also you can't really, but that gets back to the fact you're controlling the code, so you can write something that's simpler. Yeah. Like we said, it might work. It suffers from steady state, right? Eventually you're going to end up with nothing but one-line functions, and that's all your code is. It's very hard to reverse. And again, we need a very complex mutation engine to kind of like collapse them, and that's would be pretty big to have as the payload of a worm. So there are some snake oil mutations too, things that just don't help you at all. I mean, yeah, they'll help you get around a really brittle and very static regex that someone's using, but already we see that people like WebSense and FinGen aren't using those anymore. So it's like we said, it's worthless if they're performing any type of analysis. Things like white space and comments, they immediately get stripped.
Which is kind of a cool thing, actually, because then you could hide code in white space. Because if they're going to run static analysis or something against it, you hide your code in white space, and like the little bit that you actually run is not code that it can see.
We actually have this, I gave a talk yesterday. Brian Sullivan and my coworker of mine are writing a book about AJAX security that actually you can get on Safari now. But we actually put in the book code that is trying to show how you can't look at JavaScript and figure out what it does. It takes code and encodes it as white space. So you give it a block of code, and it converts it to white space. And what you end up with is this block of code with a comment, what looks like a long white line, another comment, and then a little function. And what the function does is it says, hey, let me do a string search and find the beginning of that function and the end of that function. And what's actually in that white space is a tab is 0, a space is 1, and a character return line feed tells you that you're done. And so it's 7-bit ASCII representing the actual code.
And
we encode it into white space. And so the great thing is, if you're performing analysis on this, the very first thing that happens is they disregard all the white space. So if WebSense or FinGen is running it to its steady state, they won't ever see this because it's all going to get stripped away. We also didn't do code block reordering. If you're going to reorder where your functions are, the function declarations, not where they're called, that doesn't really help, right? I mean, if my code uses 3 functions and they're normally ordered 1, 2, and 3, and I renumber them so it's 3, 2, 1 or something like that, I mean, the code's still going to run, but from an analysis point of view, that's not a very interesting mutation because once you start getting into building abstract syntax trees or parse trees, you're going to go where the location of a function is or the location of a code block, it doesn't matter. You're not really thinking about order at that point. You basically have abstracted that away, if that makes sense. Are y'all really bored or good? Okay. I know we're going really fast, but I know that, and I know some of this is kind of complex, but. So source code no ops. This is really easy to do, and there's tons of them, right? I can build ifs, if false in a code block, and that'll never run. If true, and then the very first thing is a break. I can multiply variables and them with themselves, double knot them, divide by 1. I mean, there's tons of stuff I can do. And those literals there, these no-ops are actually good because now, x times 1. Now I've got a variable, but I also have a numeric literal that I can then break apart. And so it's fertile ground for letting you have lots of mutations, but it's really easy to detect, especially with static analysis. Who here's compiled and never seen the warning unreachable code detected, right? Because the compiler, when it's actually doing code generation, can say, wait a minute, this code block's never going to run. So identifying no-ops, and